Hi guys, jumping back on to bring you 9C, Minerals as Resources, and we know this is our last section in Chapter 9. The two main points from 9.8 were God made us in His image, and if we carry out dominion in the way that declares His glory, we must learn how to appreciate the beauty of minerals as well as their usefulness. Section 9.9 is native minerals, and it divides it up into metal and non-metal. So when we think of beautiful minerals, gemstones will be the first to come to mind. But remember precious metals like, if you're here right now, it's 1:10, so you are heading on to electives if you're on campus with me right now. So precious metals, so we can think of gold, silver, copper, and even platinum are also minerals. You can find most of these metal elements in their pure states in nature as native minerals. And the types of minerals that are most likely to be found in placer deposits are native metal. So they could fill in the cracks in rocks called veins, or they could be found in chunks, in nuggets. So here is showing you some veins of how it's filled in. When rocks containing these native metals erode, their particles wash into nearby streams and onto beaches. These mineral sediments are called placer deposits, which can be rich sources of precious metals. Most native deposits of the industrial metals like copper and iron have been used up, and they are now obtained only from ores. So here we can see copper, and then here is a picture of iron. Native metals, like most metal elements, are denser than water, and they're bright metallic lusters. The colors are distinctive. The gold is bright yellow, silver is dark gray because it tarnishes, so you can think of fresh surface like a mirror. And then native copper, which is dull red, and platinum is steel gray. Gold, silver, platinum, and copper are all good conductors of heat and electricity. Copper tarnishes, a tough surface layer forms, and the layer seals out the oxygen and resists further corrosion. Copper is used in plumbing pipes and corrosive proof architectural coverings like roofs. And we can see right here, so here is a pipe of copper that is not tarnished, and here's one that is tarnished. Non-metals. So native minerals can also be elements that are non-metals. Diamond would be an example, is a pure form of carbon. So remember, C from our periodic table, it's a pure element. And what carbon is that carbon is like hydrogen, oxygen, or lead, or any of the others on the periodic table. Carbon is very abundant. It exists in pure or nearly pure forms, such as diamonds and graphite. But can also combine with other elements to form molecules. So I give you a picture of carbon right here with the diamond, and then a little fun comic. Prospectors may find diamonds in placer deposits, but usually they are mined in diamond pipes. A diamond pipe, so they're underground remnants of magma necks of extinct volcanoes. Diamonds form under great heat and pressure as igneous minerals, and they are usually pale yellow or colorless, but they can be red, orange, green, blue, and brown. The size of the stone is measured in a unit of mass called a carat. So here is like a diamond mine. So you would see your diamond pipe going down, and so what they're doing is they're drilling down here, and you can see that they drill over. And here's where all the stuff that they're wanting to mine out is. And there is a YouTube video that I have linked that's coming up that I want you to watch about this. The element sulfur can occur as a native mineral in bright yellow deposits. It's found near the rims of volcanoes and in sedimentary beds deep underground. So here's a picture showing you that on the rim of a volcano, and then also another picture of sulfur. Sulfur has a hardness of 1.5 to 2 and can occur in several crystalline forms. It melts at 235 degrees and burns with distinctive blue flame. The rotten egg smell from some spoiled foods is due to that toxic sulfur compound. And we talked about that sulfur being in water and how like sometimes you'll have that smell when with the water, and that would be the sulfur in the water. It is also one of the most important elements to the modern industrial nations because it's a main component of sulfuric acid. And the acid is essential and compound for industrial processes, so made by refining and processing petroleum and coal. Moving on to section 9.10, and we're on page 235 if you're following along in your book. Mineralogists group minerals with similar, sorry, there's the bell again. You're late to 6th period if you're not there yet. Mineralogists group minerals with similar combinations of elements together into families, and each of these families has its own special properties and uses. So they're going to break it down into different families. So one of them is silicates, and they're made up of 25% of all known minerals and about 40% of common ores. More than 90% of the Earth's crust is made of silicates, and there's a really good chart there in your book on 215 that shows you this. The class contains mainly silicon and oxygen, and feldspar is the most common silicate mineral in the crust. Quartz is our second most common, and it's pure silicate compound called silica, and SiO2. So remember we were talking about compounds earlier. So look here, we have two, I'll turn on your little pointer. So see here, we have two different elements, so that's making it a compound right there. All right, oxides. So oxides are minerals made of oxygen and some other element using metal. These are economically important because they are chief sources of major metals in the industry. Most metal ores are found in this family. And then sulfides, so we're turning our page to 216. Minerals are made of one or more metals and sulfur. So they're again economically very important to us. And many sulfides are opaque and have color streaks. So our examples are like copper sulfide, and then cinnabar, mercury sulfide, and pyrite. So you probably heard of pyrite before, fool's gold. I'm sure you've talked about that in history before. So pyrite is also called fool's gold, which is iron sulfide. There's a picture of it right there too. Then moving on to carbonates. So minerals containing one or more metal ions and the carbonate ion. So the ion particle is made of one carbon and 3 oxygen atoms. Carbonates are another of the major rock-forming minerals. They form vast beds of sedimentary rock, and many solution caves are dissolved out of carbonate rocks. So we can see right here at the cave, a solution cave. And look how pretty that is. The strange, beautiful formations of these caves come from accretion. Remember we said that the crystal's growing, so accretion of the carbonate minerals. And then there is a little YouTube video that I want you to watch, so just link it up later and watch that on solution caves. Carbonates are useful in manufacturing many different products like cement, paper, and steel. Halides, so this is our last little section for 9.10. Mineral salt compounds. They form when atoms such as sodium, potassium, magnesium, or calcium combine with fluorine, chlorine, bromide, or iodine. The most familiar halide mineral is halite. So that's really important right there. Halite is a compound of sodium and chlorine, so NaCl. So again, a compound, 2 elements. So that's what our table salt is, actually. Another important halide is calcium chloride, and that's what the kind of salt they use on icy roads up north. They would put the salt down and like help it melts the ice and the snow. And then there's another little YouTube video. It's pretty short, so just watch that in a little bit. The salt that they use is less damaging to cars and plants than regular table salt would be to melt the ice. That's why they don't use the actual table salt.